Hi, this is Cameron with CanCam CNC Machines. Today we're going to be walking you through our tramming training video with our B144 machine. Starting off here with the materials and tools you'll need. You'll want a 30mm wrench, a 21mm wrench, a variety of shims, and some snips here to cut the shims to size. You'll want a set of Allen keys. You may want a chalk marker. Here we have an ER20 nut, our tramming tool with the appropriate collet, and finishing off with our granite block. So we're going to start off with our nut, our collet, and our tramming tool. We're going to install the collet into the nut. We're going to install that part way on the threads. We'll bring our tramming tool up. And then we'll snug that just with our hands for now. Until the tramming tool is secure, we'll give it an extra hand tighten, and our tramming tool is installed. To ensure that we have a flat surface to tram our machine, we're going to take our spoil board off. Next, we're going to remove the gasket from the bed here to make sure we have a flat surface. And it's also good to give the PVC bed here a quick wipe down. Similar to the bed, you want to ensure that the bottom of your granite block has no debris. And then we're going to lightly set it down on the bed, and we're going to check to see if it tips. If you hear knocking, the surface isn't flat, so we're going to adjust until we find a spot on the bed where it doesn't rock. Next, we're going to bring our tramming tool over our granite block here and locate it in the middle of the x-axis. We also want to locate it in the middle of our y-axis on the block. And then we also want to bring it down so that it's touching the block. And depending on your tramming tool, you'll have a different depth that you'll want to reach, making sure both parts of the tool are touching the block. And you're good to move on to the next step. So we're only going to use one dial for each axis. Our starting position when we got our correction factor is going to dictate which dial we use. So our y-axis is going to use the front dial here when the dial is facing to the left. And when we're doing our x-axis, when the dial is facing forward, we're going to use this dial on our left for the x-axis. To help with accuracy, we're going to use our chalk marker, and we're going to mark where each of the ends of the tramming tool touch the block with a small X. We're going to do the same thing with the y-axis. We're going to lift up each of those, set them back down, make sure it's perfect on the y-axis, and mark off each location. Beginning on the x-axis here, we're going to do a check for runout in this tool. So we're going to slide it from the left marker here to the right marker there. First, we're going to zero this dial. And then we're going to move our gantry to the right. Till it hits that marker. And then we're going to record the value we see there, which would be approximately -4 thou to about -5 thou. We're going to do the same thing that we did with our x-axis on our y-axis now. So we're going to want to move it back to the center. Line it up appropriately. And then rotate it to our y-axis. We're going to zero the front of our dial here. And we're going to slide it to the marker at the back. And same thing as the X, we're going to record our value. We're going to move our dial back to the center of the block. And we're going to start with our x-axis. So to check our tram for this machine, we're going to rotate our dial entirely around. And we're going to check the value. Here we can see our dial now shows approximately -2.5 thou. And we're going to compare that value with our runout value, our correction factor that we got before. Now that we've rotated our dial and checked our value, we can calculate the difference. So looking at the values that we got here, we can calculate the difference between them of 2 thou. Which is actually a good recommended value to aim for. Anything better than 2 thou and you should get good results. We're still going to go through and I'll show you how to correct that to make it even better. Now we're going to move along and check our y-axis tram. We're going to make sure this dial is zeroed and then we're going to rotate it 180 degrees. And we'll check the value that we get on the other side. Here you can see we got a value of approximately -12.5 thou. We're going to write that down and compare it to our correction factor here. Now moving on to the actual tramming portion of our video, you always want to start with the y-axis. The y-axis is where we're going to use our shims to correct the tilt. And after our y-axis is good, then we'll move along to the x-axis. So moving on to our y-axis here, we are approximately 16 thou out. So we're going to sort our tools out here and get our materials ready. You're going to want the following items: a variety of shims of different thicknesses, your Allen key, and the snips to cut the shims down to size. To begin tramming for the y-axis here, we're going to loosen these 4 bolts. We're going to use a 6mm Allen key and loosen all 4. So every machine is a little bit different. Our shim size is going to depend on a variety of factors: how much we're out by, the angle of the plate, the distance our shim is going to be from the bolt. All of that is going to contribute to a different value. So we're going to work towards estimating what size of shim we want to place behind there. And we're going to correct off of our first check. So I like to start, considering we're about 16 thou out, with the thickest shim that we have, which is 3 thou. we're going to cut a rectangle of this. And we're going to cut a second one because we want both sides to be the same. We're going to take both of these. All 4 bolts are loosened here. We're going to pull the spindle off of the back plate. And we're going to slide a shim behind there, just enough that only a small portion of it pops out. And we're going to do the same thing to the other side, making sure that this shim does not fall. And we typically want that as close to the bolt as we can without interfering. Once those are secure, we're going to tighten all 4 of these up. We don't have to tighten them too much right now, but we are going to make sure they're snug. And all 4 do have to be tightened. And then we're going to test our tramming tool. Now we're going to check with our tramming tool. We're going to start at our original location and change it to 0. And then we'll spin it around to the other side. And we're going to spin it 180 degrees. And we're going to compare our value to our correction factor. So you can see here, we are closer than we were before. We are at approximately -12 thou. We're now around -9 thou. And our goal is still to get all the way back to about 3.5 thou. So we're going to have to add a few more shims. And so I'm going to do the same exact thing I've already done. I'm going to take our thickest shim, which was 3 thou. I'm going to cut 2 slices of that. Set those aside for a second. We're going to take our Allen key and loosen the bolts. And we want to loosen them to a point where we can add the shim behind the plate. We're going to take our shims, we're going to place them in the same exact location that our other shim already is. Keep in mind, you may have to take that shim out, stack them together, and then put both in at the same time. As you can see here, I'm going to do that exact thing. We're going to stack them together. I'm actually going to loosen this a little bit more. Pull the spindle forward. Slide both shims behind there. And now we have identical shims on both sides. We're now going to repeat our checking process. So we're going to spin our dial back to the original location. We're going to set it to 0. And we're going to turn it and check the value that we get. So we're getting very close. We're at approximately 0 on the dial there, so we only have around 3.5 thou to go. So that last shim, that last 3 thou shim that we installed, changed our dial approximately 8 thousandths of an inch. So we need to add approximately another 3 thousandths of an inch. So we're not going to use our thickest shim for this one. We're going to downsize, maybe to our 2 thou, or even smaller down to a 1 thou shim. And we'll proceed to verify the results. We're going to use our 2 thousandths shim here and cut 2 squares of it. We're going to set those aside and loosen the 4 bolts. We're going to loosen them a little extra to make sure we can fit 3 shims in there. For this one, because our stack of shims is increasing, I'm actually going to take these shims out. If you can't get them out with your thumb, you can use a knife to catch the edge of it. Now we're going to create our shim stacks. So we have 2 3/10 shims in each stack, and then we're going to add our 2/10 to each stack, and we're going to install them behind the plate. Tighten up all 4 bolts again. We're going to verify results by going to our starting location, looking at our y-axis dial here. We're going to 0 it. We're going to rotate it. And you can see we're within 2/10 of our correction factor. So if that's the value you're looking for, you could keep your shim stack as it is. If you're looking for a little bit more precision, you're going to have to take out one of your shims and downsize it so that you can bring this 5/10 value a little bit closer to 3.5/10. So to help clarify our value here, we have approximately 5/10 on the dial. And to calculate our tram value, we're going to take the difference between our 3.5/10 and our 5/10 here, and that's the value of how far out our tram is. So calculating the difference between those, we get a value of 1.5/10 difference. Considering we started from about 16/10 out between these two values, 1.5/10 is pretty good, and it's within our 2/10 specification. Moving on to our x-axis here, we always do the x-axis after the y-axis is good. When we're doing the x-axis, we're going to want to make sure that our shims from our y-axis correction do not fall out while we're loosening the bolts. Even though we checked our x-axis at the beginning of the video, that value is likely not going to be the same. During our y-axis correction, our x-axis rotation will have probably been affected. So we're going to have to check that again, and we'll correct accordingly. So to check that value again, we're going to 0. And then we're going to rotate our tool 180 degrees. And we'll check the value we get on the other side. As we're rotating our tool, we're going to want to make sure we watch what direction the dial turns. Upon rotating it, we could see that it started at 0 and went about -17/10. And we're going to write that down and correct accordingly. So our original correction factor that we got at the beginning, while it was in specification, it has changed and is now incorrect. We actually have a value of 0.175. So we can see that our value is a significant amount away from our specification. To keep things simple, I'm going to show you a trick on what direction we actually want to rotate the spindle, whether that's counterclockwise or clockwise. So looking at our dial here, we want to bring that negative 17 thou closer to 4.5 thou. So we're going to do some tests, and you can push or pull on the bottom of the spindle here with moderate force, and you want to see which way the dial turns. And we're trying to bring this dial clockwise, approximately to negative 4 thou. And you can see if I pull on the bottom, that's the direction we want to go. So we're going to bring our tool to the original location, and we're going to keep an eye on our x-axis dial here, and we're going to loosen the 4 bolts. Careful not to let these shims drop out. On the last bolt, we want to leave it a little bit tighter than the rest. So we've got 3 loose, and this last one we're going to be careful. We're just going to loosen it a bit. And we know that we want to move our spindle clockwise because we were pulling on the bottom and it was bringing the dial to where we wanted it to go. So we're lightly going to try to turn it. You can give it some light taps. And then you can check, you can zero it again, rotate it, and see how much closer it is to the value that you're aiming for. So checking our value here, it's moved about 5 thou closer to where we want it to be. So we're headed in the right direction. So we're going to return to our original location again and repeat what we just did. You can watch how far this dial turns as somewhat of an indicator. You can lightly tap the spindle. Looks like we've gone approximately 4 thou here, so we might be getting close. Let's do a little bit more. That looks like a good estimation. We're going to zero this here. And then we're going to rotate it and check our value. So looking at our dial here, after rotating, we're just below negative 4 thou, and our goal is negative 4.5 thou. So we got pretty lucky on our second try there, and we have it within spec. So our bolts up top here are still loose. We have the correct value, it's within our specification, but even tightening those bolts can throw out that value a little bit, maybe even just enough to be outside of our specification. So we're going to tighten those up. And we're going to check our value again and see if it's changed. Now that we've tightened our bolts up, we're going to zero and check our X value again. We're going to rotate the tool. And we're going to go around and check the dial. I can see we got a value of negative 4 thou after tightening up, so that's good. We're going to move this to the starting position for the y-axis as well, and just do a double check before we torque up our bolts. We're going to zero the dial for our y-axis, and we're going to rotate our tool. And we're going to make sure that that's still within spec as well. We're going to take our torque wrench, a 6mm bit. We recommend for this machine a torque setting of at least 20 Newton meters up to 30 Newton meters. I'm going to set our torque wrench to 25 Newton meters. And we're going to torque all 4 bolts. Now that we're done checking all our values, we've torqued our bolts, It's good to also recheck this every once in a while as part of your routine maintenance. You would do the same process that we've already walked through. Zero your dial, rotate it around, check your value, and compare it to your correction value. Thank you for joining us here at CanCam CNC for our training video on tramming your CNC router. If you have more questions or need any help, feel free to reach out to us at support@cancam.ca.